You see, in physics, we have different quantities to describe an object or its motion. Take this object. We can measure its length. So length is 14 centimeter. Say its mass is 2 kg. Say it is moved from here to here in 10 seconds. So these are all measurements of the body and its motion. Okay. Now say on this body I am applying a force of 5 Newton. So when I show it like this, I am applying a force of 5 Newton. You understand that the sun is applying a force on the body of 5 Newton from his right to left. Or if I apply a force of 5 Newton this way, you can see that I am applying a force of 5 Newton from my left to my right. Clear? Or I can apply a force of 10 Newton vertically downward. Clear? Now see, if I simply say I am applying a force of 5 Newton on this body, will you understand it completely? See, you may think that I am applying the force in this direction, or you may think I am applying it in this direction, and they on the back may think I am applying it vertically downward. So if I simply say that I am applying a force of 5 Newton, what I say is not complete. What is lacking? The direction. That means whenever I say I am applying a force of say 5 Newton or 10 Newton on an object, I have to specify the direction of the force also. That means force is a quantity that has a magnitude 5 Newton, 10 Newton, 100 Newton plus a direction, right? But other quantities like length, when I say its length is 14 centimeter, that was complete description of it. There is nothing like a direction for that. Or if I say the mass is 2 kg, that is complete. There is nothing like a direction associated with a mass. So, understood? So in physics, what happens is, there are two types of quantities. Some quantities like length, mass, etc., they have only a magnitude. But there are some other quantities like force, which has a magnitude as well as a direction. So, the scientists have given two different names for these type of quantities. They are called scalars and vectors. So, you should understand that the different physical quantities in physics are divided into two categories. Some quantities are called scalar quantities and some quantities are called vector quantities. The scalar quantities has only magnitude, they don't have any direction. The vector quantities have both magnitude and direction. Okay? Now example of scalar quantities are length, mass, time, etc. You see, they only have a magnitude, 2 meters, 3 meters, mass 5 kg, 10 kg, time 10 seconds, 1 hour, 15 minutes, like that. And the vector quantities are, examples are like this. Say force is a vector quantity. You learn these quantities later, displacement, velocity, etc. These are all vector quantities. That means whenever you want to say something about displacement or velocity, you must remember to say both its direction and its magnitude. Clear? So this is simply the difference between scalar and vector. It's not very difficult. Now don't get scared that I have to learn a new word, vector, new term, vector quantities. It's becoming very difficult. Actually, it's not very difficult. Just remember this. See, if we have an object like this, and as I told you before, if I simply say I am applying a 10 Newton force on this object, will you understand it completely? No, because you don't know whether I am applying it from vertically downward or from my right to left, right? So simply saying there is a force of 10 Newton on this object is not sufficient, right? We have to also say in which direction the force is being applied. So that means force has a magnitude and a direction. So this type of quantities are called vector quantities, as simple as that.